So GPUs is a graphic processing card. The important feature for GPUs is it has massive computing parallelisms as well as high memory bandwidth. As a result, it is able to satisfy many of the compute and memory-intensive applications that we have been used today. So the key idea here is like we're trying to model composable GPU pools as a very tightly coupled microprocessor, and then apply instruction scheduling algorithms on top to achieving the goal. Our group has been working on this for the past 3 years. We have building a bunch of system tools and utilities, but this is, to us, is just an initial point. We think we can working with many other peoples and then building more better efficient software systems to use it. Problem that we're trying to solve is how to run applications efficiently over composable GPU infrastructures. Right now, GPUs has becoming the cornerstone for the computing infrastructure for today's AI applications, scientific applications, as well as cloud applications. However, traditionally what we use is discrete GPU servers. We have GPU servers holding the graphic cards and providing for the application. And right now, with the emerging load store interconnects, which is one interconnect technology, we are able to build GPU infrastructures in a composable way. Therefore, instead of having separate GPU servers, we have composable GPU pools. Now the problem is how to run applications efficiently over these pools to satisfy the application demands, as well as saving computing cost. So this innovation is trying to developing algorithms to solve this problem. So this invention is essentially computation, allocation, and scheduling algorithms. This one is inspired by dynamic instruction scheduling from the computer architecture world. So when we look at how it works, the scheduler have 4 system components. So the first system component is a processing unit. What is a processing unit? Essentially, it is trying to view each individual GPUs as an executor. The second function unit is an instruction scheduler. What an instruction scheduler is like it's trying to taking applications and then reformat the application into instructions and then running these instructions on the executors. The third thing happening here is scoreboarding. This is kind of what we inspired from computer architecture, because in the computer architecture field, they always using scoreboarding as a central bookkeeper to know what is the status for different functionalities. And similar in our context, we also trying to using scoreboarding as a centralized mechanism. And the last one is the pipeline scheduler, is the scheduler itself. And you can see, without the first 3 components, the scheduler will not happen. The scheduler has to rely on these 3 things to achieving efficient scheduling. Combine these 4 things together, we are able to running applications effectively on these composable GPUs. One thing we want to working on is trying to building system stacks for composable structures to see how can we support other computation resources like other accelerators. So GPU is one accelerator, but there are many other domain-specific accelerators we are using today. So this is one thing. The second thing is we want to democratize this infrastructure for more applications. As we said, is like baseband processing is one application. Well, people are proliferating all the AI applications a lot. Can we also support that? And can we also think about whether this can support scientific applications? As a result, our group has built a platform called eFabric, which is a platform that based on this kind of technology and then providing computing resources for many other domain scientists. We want to closely working with industry vendors to see this kind of infrastructure actually can be used better if we have some software system support. And we can demonstrate this for this particular case. Therefore, hardware vendors is definitely one kind of use case that we are targeting at. The second kind of people I'm usually consider is solution vendors. What I mean by solution vendors, no matter people are building applications or people are building infrastructure services or people, even hyperscalers, we want to show like our prototype, even though in a small scale, can providing functionality that people want in a composable way. As a result, these kind of people we really want to working together. And then the third categories is not only students, but I usually say them is more like developers, which we want to working them together and also learn from them to see how do we build system stacks.
Hi, I'm Emily Bauer, Director of Licensing with Wharf. If you like what you've heard and want to learn more about this high potential technology, please get in touch using the information on your screen and in the description below. And don't forget to subscribe for more great videos from Wharf.